All right, welcome. Today, we are going to crack a case. A case that, honestly, impacts pretty much everything you do online. We're going to pull back the curtain on how machines actually learn. And to do that, we're going to meet two characters, a super methodical teacher and a brilliant detective. So let's jump right in. So, have you ever stopped to think about this? How on earth does Netflix just know the exact movie you want to watch? Or how does Spotify build a playlist that feels like it read your mind? It's kind of spooky, right? It feels like magic. Well, spoiler alert, it's not magic. It's actually way more interesting than that. See, behind all those eerily perfect recommendations, there are two really powerful but totally different ways that machines learn. And if you can get your head around these two approaches, you'll basically understand the AI that's running our digital world. Okay, so let's break this down. We're talking about the teacher versus the detective. Two completely different learning styles. One learns with a clear answer key, the other has to figure it all out on its own. Let's see how they work.
First up, let's talk about learning with an answer key. This is our teacher method, officially known as supervised learning.
So here's the big idea with supervised learning. It's all about labeled training data. That's the key phrase. You're basically giving the algorithm a massive cheat sheet, a huge data set where every single piece of information is already tagged with the correct answer. This labeled data is the supervisor, or the teacher, showing the machine what's what. You know, a great way to think about it is like training a junior developer. You wouldn't just throw them in the deep end, right? No way. You'd give them tons of examples of really good code and also examples of really, really bad code. Over time, they start to see the patterns. That's exactly what's happening here. The machine learns from examples to tell the good from the bad. And the process itself is pretty straightforward. First, you feed the model a mountain of data that's already labeled. Think a million emails, each one marked spam or not spam. Then, the model just chews on all that data, learning the patterns. You know, what words show up in spam, who sends it, that kind of thing. And finally, you set it loose on your inbox, and bam, it can predict if a new email is junk.
And trust me, you see this teacher method all over the place. Your spam filter? That's supervised learning. That text from your bank about a weird charge? Supervised learning. Even things like housing price predictions or a company guessing if you're going to cancel on them, it's all the same idea. It's for problems where there's a clear, predictable answer.
Okay, so that's the teacher. Now let's switch gears and talk about our detective. This is all about finding hidden patterns, and its official name is unsupervised learning. And the key phrase here is the exact opposite of what we just talked about, without any labeled examples, right? So there's no answer key. You just dump a whole mess of raw, unlabeled data in front of the algorithm and basically say, go figure it out. Find the patterns, find what's interesting in here.
The detective analogy is just perfect for this. Picture a detective walking into a super messy room full of clues. Nobody's there to tell them, hey, that's the important piece of evidence. Nope, they have to look at everything and start making connections on their own, grouping things together. Okay, these things seem to go together. But this thing over here, this is weird, it doesn't fit. They're finding the hidden story in the mess.
Yeah, and you can see it right here. The algorithm just sorts through this giant pile of data and starts finding these natural groups, or clusters. But what's really cool, and just as important, is that it also spots the weirdos, the outliers. You know, the one data point that just doesn't belong. That's often the most important clue. And this detective work is powering some seriously smart tech. It's how online stores can group customers into segments based on buying habits. Habits they didn't even know were a thing. It's also used to spot weird network activity that could be a cyber attack. And of course, this is how Spotify does its magic. It's not just grouping by genre. It's finding hidden connections between songs based on tempo, or style, or energy level to find something new you'll love.
All right, time for the head-to-head comparison. Let's put the teacher and the detective side by side.
This table really lays it all out. So let's look at the input data, right? The teacher needs everything labeled nice and neat. The detective, just give it the raw, messy stuff. And the goal? Totally different. The teacher is all about predicting something specific. The detective is about discovering something you didn't even know was there. And that leads to different applications, prediction versus exploration. Finally, and this is a big one, the data needs. The teacher requires a ton of human effort up front to label everything. The detective, it can just dive right in. Okay, so this all leads to the big practical question. How do you choose your learning path? When do you call in the teacher, and when do you need the detective? It actually comes down to a couple of simple questions. First, What are you trying to do? Do you have a specific outcome to predict? Go with the teacher. Are you just exploring the data, looking for hidden insights? You need the detective. And second, what kind of data do you have? If it's all labeled and ready to go, the teacher is perfect. If labeling it all would be way too expensive or just plain impossible, well, that's a job for the detective.
But here's where it gets a little tricky. It's not always a simple choice. Let's take one challenge, finding anomalies, right? Finding the weird stuff. Well, it turns out there are different kinds of weird. You've got your global anomalies, those are the obvious outliers, way off on their own. But then you have local anomalies, and these are sneaky. They're patterns that are hiding inside a big group, looking normal until you look really closely at their neighbors.
So to find both the obvious outliers and these sneaky little local ones, how many complicated detective algorithms do you think you need? Well, one huge study looked at this, and the answer they found was kind of shocking. For most real-world data, you only need 2.
Just 2! Seriously! The research basically said you just need a simple toolbox. One tool that's great for finding those sneaky local problems, and another that's great for spotting the big global ones. It's the perfect proof that it's never about which one is best overall. It's always about picking the right tool for the job you're trying to do.
And as we look to the future, that whole line between the teacher and the detective, it's starting to get really blurry. It seems like the future isn't about choosing one or the other, but about getting them to work together in smart ways. And this is leading to some really cool new areas. You've got semi-supervised learning, where you use just a little bit of labeled teacher data to help the detective get started. And then there's self-supervised learning, which is, well, it's pretty mind-blowing. That's where the models are so smart they can actually create their own labels from raw data. They basically become their own teachers. So here's my challenge to you. The next time something magical happens on your phone, a photo gets tagged automatically or Netflix recommends the perfect movie, stop and ask yourself, was that the teacher at work just following the rules it was taught? Or was it the detective uncovering a brand new pattern that no human had ever seen before? Now you know what to look for. Thanks for joining me.